Okay. Why don't we get started? If I'm reading this correctly, the only thing people have on top of their mind is the flat buffer. Flat buffer stuff. Okay. I guess Rock or Adam. I know there was a mailing list discussion on this where the doc was published. I don't know if you had any thoughts on that thread or what you guys are.
Yeah, we're following this closely because we've kind of dealt with this problem in the past and have some kind of custom hacky workarounds. Often we want to read just a subset of columns or a subset of row groups, and we've noticed the overhead of reading all of the metadata can actually be quite a bit. Yeah, and sort of following along the discussion, I think there's a couple of main concerns I've noticed. One for us is the limitation of reducing the maximum size of row groups to 2 gigabytes. I've reached out to people within G Research to get some feedback on that, and the feeling is, we can probably work around that if we had to, but it would be kind of annoying. I think we often sort of use lower level APIs where we're writing row groups explicitly rather than have some framework that sort of automatically breaks up data into row groups, and so that'd be kind of an extra thing for people to care about. And it is sort of a step back compared to the current format. Yeah, so kind of against adding a new limitation. And I think there's kind of agreement on that. I don't know, did anyone have any thoughts on that part?
No, I think the main people on that discussion today, I haven't had time to read through the latest proposal. I know I was a little bit concerned about it before. I think there was I think those types of regressions are things we should try to avoid if possible. And I think this gets back to something that, we talked about before. Flat buffers might not be the ideal thing here, right? Like if you need to break it down to 32 to make it work within flat buffer, it could be problematic. And then so we can talk about some more. I don't know if there's wiggle room there, how much that particular optimization actually saves.
Yeah.
I think Andrew, have you guys tried writing a custom parser? I mean, I think
Ed's in the middle of doing it. Like one of the contributors to RRS is doing it. He has micro benchmarks now, so he doesn't have but it's 2 to 3 times faster than the thing we currently have.
Yeah, which is great. I'm kind of curious from G Research use perspective, is 2 to 3 times enough of a performance improvement to meet your use case?
Yeah, so we previously had use cases where we were reading a really small number of columns, and so it was more like 100 times faster is what we were getting by skipping metadata. I don't know if that's actually true anymore. We've sort of rearranged things in some cases, and maybe that would be enough. I'm not sure. So our current workaround is we built this thing called palette jack, which just copies the thrift metadata, but sort of breaks it up into a form where it's sort of indexed by row group and column. And so you can just ahead of time, you have to know which columns and row groups you're going to read, and you just pass those bits of the metadata and pass that through to the C++ error library, or Parquet library, I should say. And so, yeah, with that, I tried to dig up some benchmarks, but I haven't found anything. So that might be something I need to find it might help with this discussion. Yeah, I think that was giving us much more than a few X faster. It was more like 10 or 100 times in some cases.
Yeah, so
that is maybe a bit of an edge case.
well, I just want to be clear too that 2 to 3x faster we're seeing is just parsing the entire footer again into Rust structs and saving. For everyone else's benefit on the call, what the Rust reader does, and I think this is basically what all open source readers do that I know of, is they take the Thrift compiler, generate code to parse the Thrift headers into, or the Thrift footer into whatever objects are generated by that Thrift compiler, and then copies it again into structures that are reasonable to work with, not the auto-generated stuff. And so the theory is if you just write a custom parser, the Thrift parser generator or whatever, but just straight up the custom parser into the structures you want, it's faster simply because you're not doing a bunch of unnecessary work. And that so far seems to be the case. Another point I wanted to mention is that because we're going to control the parser, it's much more imaginable that you can do stuff like configure the parser to only decode statistics for columns you care about, for example, right? Where right now the auto-generated thrifting just always parses the whole thing all the time because that's what the Thrift compiler gives you, versus once we have our own parser, we'll have much more control over only parse some of it. Now, yes, you still have to scan the bytes, right, to figure out where all the fields start, but you don't have to like do a lot of the like allocate strings and copy stuff around or whatever, potentially. So I don't think we have any like benchmarks yet to show that or real results, but that's definitely on our mind. Right? If you're only going to read 2 row groups, you don't need to parse the metadata in detail for all of the other row groups.
Yeah. And actually, yeah, one of the interesting bits of the flat buffer discussion was you kind of do still need to not parse the whole thing, but often look through it and check the offsets are valid for sort of security and safety. Because yeah, the results Alcus were presenting were kind of a bit underwhelming, but I think they included converting the whole flat buffers structure into existing Thrift-based formats, which probably has a lot of overhead. So it's not really clear what the like how much performance benefit you can really get from the flat buffers footer based on the existing results.
So Andrew and Adam, you guys mentioned this custom parser which allowed you to skip the fields, either stats or row groups that are not needed in the query. That achieved 3x?
No, that's the dream. We're working towards that dream.
Okay.
3x was just not using the structures generated by the Rust Thrift parser generator. I don't know what to call it, compiler thing. And instead just writing our own custom parser that went directly from Thrift bytes into the Rust structs.
Okay.
And those are clear, those are micro benchmarks for parsing footer, like.
And is this specific to just Rust? Like you mentioned 2 memory copies that end up happening from the serialized representation to some structures and then to Rust structures. Does that happen in C++?
To the best of my knowledge, yes. And also Java.
I thought C++ had string views in certain cases, but I don't know if we're using them in the canonical implementation. I thought we might be, but I don't. We need to go back and check. So it might end up doing some sort of copy anyways, but I thought there might have been an option for string views. Maybe I was hoping there was an option for string views in C++.
Is the copy needed for something to work, or that's completely unnecessary?
I mean, I think it's like whatever your memory model is and like what you're disposing of and not, right? Like, so I think Rust is a lot better at this, where like if you don't need to copy, it's very good at like tracking your usages to make sure you don't have dangling pointers. But like in the core Thrift structure, the serialization format is just like a UTF string, so you don't really need to copy it if you are willing to keep around the raw bytes from Thrift. Like in the past, like the overhead of like the integer decoding, which is like variable width, has been raised as like where a lot of the time is spent, and I haven't done any benchmarking myself to understand this.
Interesting. Yeah, no, I think this would be quite powerful, as in if these like memory optimizations or some way of hinting that you can skip stats or row groups will not need a lot of surgery on the reader side, and like the Parquet, the thrift structure will still be performant.
Yeah, I mean that's the theory that we have, which is if you're going to write, the query engine already knows what columns you want, and often if you're reading 3 columns from like a huge file, right now most readers, certainly the Rust one, will just decode the entire metadata for all the columns, even if you're only going to read 3, right? And that includes a lot of stuff like statistics, and especially for like variable length strings or whatever. Those can be pretty expensive. So the theory is, if you can push more of the information about what parts of the footer you're actually going to use into the reader and parser, that you could be quite a bit more efficient.
Got it. Thanks.
Couldn't you do that with the custom thrift parser?
Yeah, I think that's the hope, is that using a custom thrift parser, we can do that type of optimization. Whereas right now, because it's like 2 levels away from, it's like basically generated code, that we didn't feel like we could actually do that.
I see.
And we'll see. Like this is all the theory. We'll see how good it actually works when we get it all done. It's still probably a couple months away.
For the Haskell implementation, I didn't have a thrift parser, so I think I rolled one from scratch, and I haven't quite benchmarked it, but the metadata for the files I've been reading are typically small enough that doesn't, like, the efficiency of reading specific metadata and not reading the rest of the structure, I'm not sure is currently like dwarfed by the rest of the reading. In what situations do you imagine this actually making a difference?
The use cases I've heard is when you put something like 10,000 columns in the file. I don't personally have those use cases, but I hear they exist and that people like them. So,
we have those use cases. I don't know if I'd say we like them, but yeah. Yeah, we have sort of tens of thousands of columns and like hundreds of row groups in some cases. We as well as that palette jack tool I've mentioned, we also now have some workflows where we sort of vertically partition Parquet files, sort of ensure they're sort of the rows are aligned across files to work around this problem too. But that's kind of solves other problems as well.
Do you guys have your own Parquet readers? Can you tell, or is it you just use the open source ones?
No, just the open source ones. Yeah, the C++ and Rust based ones.
Oh yes, that's a good question. I've had the same thing. So with your files with 10,000 columns, is it sparse where a lot of them are nulls, or are they all dense? Or is there a mixture?
It's not nulls. I think those real, feature store kind of use cases where I haven't seen that a lot, but it's almost always, deep structures, nested structures where those columns blow up. And even if you have like 5, 6 of them, each one having, let's say, 100 of these roots, subroots, you can easily hit 1,000 columns.
Yeah, I think most of our data would be dense as well, but we've got sort of a few different use cases, and there's definitely some sparse ones as well.
Yeah.
I was wondering about sparse because like variant is another potential way to encode sparse data, right? Like instead of pivoting everything out to its own column, but if most of them are missing, you could stick it into one column that's variant. But that also depends on like if you actually want to be able to quickly query those columns or not. So, yeah.
Yeah, I guess so. Alpha's isn't here, right? So I don't know if there's any obvious next steps for the flat buffer footer work. I mean, we're definitely interested to see the results from the Rust parser, and it would probably make sense to eventually try to do the same thing on the C++ side.
Yeah, I mean, I think just like it seems like Alkis is like slowly driving this forward, so I don't know that there's any immediate next steps. I think we probably need to figure out like what the trade-offs are, like how much the flat buffers gets us when not going to thrift versus like an optimized thrift parser gets us would be maybe the right decision point, because like, so we're probably pessimizing the flat buffer thing by converting to thrift structures when we don't need to. And then I think like then just like the compromises we're making in terms of regressions, and like if we like pull those out, how much it changes. Like I think if it might be worth seeing if somebody else has bandwidth to do like more of the testing on the C++ side with flat buffers, to see if somebody else could help like push it forward as well, if Alkis is like bandwidth constrained on it, on that side of things at least.
Yeah, it'd be really interesting to see if there's a way to do some benchmarks where we don't have to, we're querying a subset of columns or row groups and don't need all the metadata. If we can get that working and get some benchmarks, and if my team probably doesn't have time immediately, but maybe sometime soon we could have a go at that if Alkis doesn't have enough bandwidth himself.
Yeah, I think it probably will take some implementation work, because I think all the code is like, I'm not sure it's like in a reasonable shareable state with like this is probably proprietary to Databricks, so at least
I think they have their own parser, right? This isn't the C++ Parquet library one they're using.
Yeah, we have our own parsing stack. Okay, cool. Anything else, or I don't think anybody who joined late added something. Okay, I guess maybe
Yeah, just Steve Loughran here. I was commenting on the security aspects of the new format as well. Okay, we don't want to make things any worse. No new CVEs should be everyone's problem here. And I think people should be reviewing it, looking at that. And was writing the code, would be interesting to know what they thought risks they could be including and what they had to do to avoid them. Just so that adding two kind of footers is kind of trouble, because it means you've then got something where your front end validator may parse is saying, hey, this is nice and safe, but the back end doesn't. Think parsing an Excel file to something where the front end says this is text, and the other one says, hey, I'm going to run Visual Basic over it.
Yeah, I mean, from that perspective, like I think flat buffers is pretty solid, and it's, like if you go through the validate, I'm not sure that there's been many CVEs that will like go out of bounds if you like take the time to validate it, which has overhead, but it can go back through and look for CVEs. I mean, some of the things might just get harder to code and like easier to mistake, but those are general concerns with like the footer can like be completely off, and all code needs to be robust to that, whether it's in thrift or in flat buffers.
Yeah, we have to trust flat buff to be well written. We just have to take that as a given. It's not like written in.
Yeah, and they're all them
then
give a validate method for it though, to like guarantee
that's more.
it's
So one, validate. Two, by default validate. So people shouldn't be benchmarking with validation turned off would be nice. I think would be a good rule. The other thing is, I think we shouldn't be trying to introduce, let's describe it. Anything mapping from that flat buff into data structure should be written assuming that something could well be malicious. I think that's about it.
Yeah.
If we're doing that anyway, when from thrift to native, then they should be paranoid there as well.
Yeah. Yeah, no, I think that's security is certainly a concern. I don't know which has had more CVEs, flat buffers or Thrift in general, but like if we're going to like write our own custom Thrift parser, then that also has like a lot of areas to get things wrong in C++ at least. So like that balance also has to be struck. Like Rust probably has a lot better guarantees here.
Yeah, the stuff we haven't used, it's called unsafe in Rust, where it turns off a bunch of checks. So I think what we'll have will be, it won't introduce memory safety problems. You might get like weird errors and panics and stuff, but not memory safety problems.
Oh, no panics.
Like,
I'm
I'm trying to get rid of it, but even that's not a memory safety problem. It's just it's just a crappy user experience.
Yeah. Oh, yeah. Okay. Okay. Anybody else want to bring anything up? Going once, twice.
What happened to the statistics of NaN counts and null counts in the floating point statistics? Or what is that just like bogged down with the weight of consensus building?
Is that, well, I need to go back and review that thread. I thought there was like a proposal that made everybody happy. I'm guessing the next step is somebody actually needs to like pony up the time to implement it. And like I think was Ed already did like an implementation of the old thing in Rust, and I don't know how much more work it is to do.
I think we have two implementations of like both proposals. We just don't have one that's like the combined proposal or something like that.
Okay, yeah, but I think at this point it's probably implementation. Have to go back, read the thread, and like see. So it's, if there's something in Rust, it's probably somebody needs to like take the time to do it in Java, and then we can close it out.
We don't have the thing that's in Rust isn't complete.
Right. Okay. So
to fix that.
Yeah. So just generally, like, I think it might get people moving, saying, "Okay, we implemented the final, like, the full proposal on Rust. Like, any volunteers for Java, and we can maybe make that happen."
Okay.
That's the last I saw. That I haven't heard of anything. I don't know if anybody else has heard anything of it or has a strong interest in making it work.
Everyone's favorite topic: NANs and floating points. No.
No. I would guess that like 50% of the engines just have bugs here that nobody has really noticed. But I don't know.
Dictionary encoding NaN values is something I think is seen fixed in a few different implementations.
Only 50%. Yeah, no, it could be like, closer to 90. I'm not sure. Net like floating points are harder than anybody realizes, I think, which is the problem. I'll let me just make a note of that.
I was just curious as well if anyone from this group is going to the Arrow Summit in Paris that's coming up soon. Be keen to discuss some more of these things in person if anyone's going there.
Yeah, no, it'd be a nice trip maybe, but doesn't fit into my schedule. Paris is a long way away for me.
I accidentally ended up in Paris last week, but that was due to a navigational error. Won't do it again.
Yeah.
I don't know, Mike, if you're as far as Adam though.
Yeah, I'm in New Zealand, but I was actually going to be in London visiting some G Research colleagues anyway, so I'm making the trip over to Paris.
Yeah, I didn't realize you're in New Zealand. That's yeah, you are a trooper for doing that. But
Take the train if you're planning to go from London to Paris.
Yeah, definitely. Yeah.
Yeah. Cool. See you guys, I guess next time then.
Thanks, everyone. Yeah.
Bye.
Right.